Ignorance of the law is no excuse, and that applies to both legal and chemistry situations. As we continue our study of the behavior of gases, you can't be ignorant of any of these laws. Check out this problem. A sample of gas has a volume of 201 liters when its temperature is 293 Kelvin and its pressure is 224 millimeters of mercury. What volume will the gas occupy at STP? Do I need to use Boyle's law or Charles' law? Actually, neither of them will work. You see, with Boyle's and Charles' laws, either temperature, pressure, or volume remained constant, while the other two changed. But in most real-life situations, all three variables will change at the same time, like in the problem I just mentioned. That's when a law called the combined gas law comes in very handy. And sometimes a fourth variable, the number of moles of gas, is needed to properly describe a sample of gas. Well, that's when a law called the ideal gas law is used. Sounds like a lot of laws, doesn't it? Well, hang on, because in addition to the combined gas law and the ideal gas law, today we're also going to discuss Avogadro's law, Graham's law, and Dalton's law of partial pressures. I think this is too much for you? Forget about it. Just pay attention and practice with your local teacher. Ignorance of these laws is no excuse.
In this lesson, you will use the combined gas law to calculate and explain the relationship of the temperature, pressure, and volume of a gas. You will state Avogadro's law and explain its significance. Using the ideal gas law, you will calculate pressure, volume, temperature, or amount of gas when the other three quantities are known. You will state Graham's law of diffusion and use this law to explain the relationship between the molecular velocities of two gases and their molar masses. You will also use the concept of molar volume in calculations of gaseous products of a chemical reaction. And you will use Dalton's law of partial pressure in various calculations involving mixtures of gases.
Boyle's law tells us how the volume of a gas changes when its pressure changes, but the temperature remains constant. Charles' law tells us how the volume of a gas changes when the temperature changes, but the pressure remains constant. But in most real-life experiments, we need to know what happens to the volume of a gas when both the pressure and temperature are changed.